Okay, and a good morning to everyone. And that was Patsy Cline, and what was the title of that one, Jonathan? Strange, as in strange numbers. Okay. Lots of things I want to talk about this morning in terms of the course. First, I'm going to go to the laptop, and we're going to go to the Math 20 homepage just to bring you up to date. So let's go to that. And this is the video-based Math 20 homepage. What ultimately will be that. And then coming down through here, we get to the spring 2009 schedule. And I told you that I would go ahead each week. I did this morning at about 5:30. And what I have here, as we get that page, I hope coming up momentarily. Let's come off there for a moment, Jonathan, until the computer responds. The thing I did was go in and set up the homework assignments for the entire week. Those are now set up for the computerized homework base. And what I am giving you is until 11 o'clock. They go on at 9 a.m. each day. So the new one's at 9. So if you want to get a start on it, you could, and it'll go until 11 o'clock the next day. And that's on 2.2, 2.3, 2.4, and 2.5. So that's been done, and so let's come back to the computer. This is the schedule of classes. This is week 1. Of course, we've already been there. We've gone through the second week. We're in week 3. And I'd like you to note, as I come over here, week 4 is the first exam. So that's not this week, but the following week, and it'll be in the first 2 chapters, even though we will start covering some new material in chapter 3. So I'm going to go back to the document cam, and we're going to go to week 3. And as we do that and slide down here, what I wanted you to see is that the homework assignments are listed. Here is 2.2, and I have the assignments listed. And as we come down now, as I just scroll down, you'll have the second one for, this will be tomorrow. And note I put odds, 1 through 29 odd. That means like 1, 3, 5, 7. Then we have 2, 4, a multiplication, and that one is a very long assignment. I'll just scroll over a little bit. So they're starting to get a little bit longer there. And then finally, on Thursday, okay, we have a little shorter assignment coming across. Now, what we're going to do this week is focus on the integers. That means positive and negative numbers. And we're going to focus on addition, subtraction, multiplication, division, and order of operations. All that. Now, some things that related to this. This morning as I was setting up the assignment sheets for Course Compass, that's my math lab, I checked your grades and how things are done, and things look good in the sense that you've had a chance to get in the computer. Your grades are very high. That's what they should be. But I want to talk about some related topics, and that is you've got to be very cautious that as you do that, when you go through the problems, you can make a couple wrong answers. You can come through and finally figure out what you're supposed to do. But what you have to be sensitive to is if you make a mistake and then you do a second one, you make a mistake and you finally get it, and that's consistently what's happening, then you need to be spending time in addition to that to where you can get an answer the first time through and get it correctly. Because in the test, you don't have the option of making an error, seeing the correction, making an error, seeing the correction, and finally getting it right. On the quiz, we had the quiz for some of you here, of course, on Friday, and others of you came in during the in-between time this morning and finished it. I've graded the quizzes that were from Friday, and an observation I'm making is something I need to talk to you about, and it has to do with time available, and I think the way that you need to practice beyond what you're doing on the computer. There were no A's in the quiz. And the grades are basically one less than I would expect across the board, which is telling me that the homework time that's being spent isn't enough to do well in the quizzes. Now that sounds like, I think of that and I think, okay, I'm not happy about that, because if the quiz grade reflects what you're doing on an exam, then the exam is not where I want you to be in terms of those grades. So that tells me something has to change. And I would say possibly if you're just using the 9 to 10 o'clock hour to get your homework done, that's not enough. Okay, you need to probably 2 hours a day for each day in class and homework. And if you're allowing 1 hour, not enough. And so I was not pleased with the quiz grades, and then Sarah and I talked over dinner about quizzes, and she was sharing with me what happened in her pre-calc and another class she had, and basically her quiz grades were worse than mine. And so I thought, okay, maybe that's just the nature of quizzes, because I don't often give quizzes. This is the first time I've done this probably in at least 10 years of doing weekly quizzes. And she does it quite often, but her grades on the quizzes she gave this last week were a disaster. Mine were just bad. So bad's better than a disaster. So it doesn't say that, things are going to stay that way, because certainly I know her grade distribution is such that it looks very respectable at the end. And so it says something, though, about being prepared for quizzes, and I'm going to talk about a couple of the problems on that quiz this morning before we go on. But what it is telling me that there's a difference in what you're doing in the computer and what you're doing on a quiz. And you need to be very conscious of that, because I don't allow you to take the quizzes nor the tests on the computer. So that means you need to be able to sit down, carry through that work, and I haven't had a chance to see what you did last week that I asked Larita to sign off for you that your work is done. And I need to see that to get a better idea of what's happening. But my first reaction is, we are not doing as well as I expect you to be able to do. And I don't think it has anything to do with talent. I think it has to do with discipline, staying on task, and putting the time in. And that's where I think we're not where I'd like you to be. One of the things that's in my mind is the quizzes give you an idea of what I'm seeing as important on a weekly basis. And so what occurred to me as we were talking about this over dinner was maybe the way to approach that to get you very serious about the quizzes is that I'll include on the test problems from the quizzes that you take at the end of the week. So not all the problems in the test will come from the quizzes, but enough of them you really need to look at those problems and make sure you can do them. And then there were some DAEs on that quiz, which I want to look at. And so the time factor, I tried to be very flexible in that in terms of time. It was intended to be shorter than I think you took time on to do it, but that's neither here nor there. At the moment, in a test, I would probably give you 20 questions in an hour's time. So that's one way of putting it in perspective. So an hour's time is 60 minutes with 20 questions. That's 3 minutes per question. I had 5 questions, so I thought about 15 minutes to 20 minutes. And that didn't appear to be quite as much time as you needed. So there are a couple things going on here. And it's mostly fine-tuning what we are doing. But I want to look at a couple problems in particular. These are not the solutions. These are just the problems. This is the first one I gave you, given the following. Now that was a parallelogram. That was the one new shape that you had in this particular part of the book we haven't done before, correct? We've done rectangles, we have done circles, we've done squares, boxes, spheres, etc. There were 2 ways you could have done this problem. One is think of cutting this out and just putting it over here. Or you could have remembered the formula for the area of a parallelogram is the base times the height. And a lot of you said 6 times 4. What did you have to see? 3 and 6 is 9, and 9 times 4 is 36 square inches. 9 times 4, because you have 9 for the base, 4 for the height. Now the 5 isn't the height, that's the diagonal, which I did here just so you can see that's a right triangle. That established that this is the altitude, because that meant you had a 90 degrees. Now I agree that that wasn't quite as easy a problem as I could have given. But as we come off there, you were expected to write the formula, the substitution, and the answer. Rules stayed the same. And I had a lot of you just give me an answer with no formula and no substitution. Now, I don't think that problem is so hard. You just weren't careful enough. Okay? And so if you got a wrong answer, 24 square inches, that's an excellent wrong answer. Okay? Now, coming back to the problem. If you had thought of cutting this triangle off and putting it over here, then you just have the area of a rectangle, but its base, again, is going to be that 6 plus 3. So that problem should have gone a lot easier. That should have been a problem in 30 seconds. Area equals base times height. Substitute 9 inches times 4 inches, 36 square inches in 30 seconds. Okay. Next problem I gave you. Coming to the document cam. That is right out of Math 10. A diagram like that had been done many times on the board, on tests, and I wanted the area inside. It was a little bit different than the problems that you'd done where you just had rectangles, but I expect you to be responsible for what we did on a formula in Math 10. You had 2 rectangles, an 8 by 10 here, another 8 by 10 here, or you could have just said 10 by 16 for 160 square inches. You had a 6, 8, 10, that's 3, 4, 5 times 2. That is your triangle. That is just 1/2 base times height, so that would have been 24 square inches there. And then all you had to do is take the circle and realize the circle has an area pi r squared, so you're dividing that by 2, and you had to remember that the diameter was 8, so the radius was 4. Okay, coming off there. Now you haven't reviewed that in a while, and I understand why that may have taken more time. That problem, if you haven't reviewed it in a while, don't remember your formulas, would nail you. What are you going to do having seen that problem? Go back and look at the formulas and make sure that on a test, should I give you something like that, and now that I've found you weren't able to do that well, I'm very interested in giving you another opportunity on an exam. That's non-subtle. Know how to find the area of a figure like that. Let's come to this one, because this was the new wrinkle that I gave you, and this one did not go well at all. LWH. So I'm going to go to the board behind me on this, Jonathan. We have the volume is equal to the length times the width times the height. That's the formula for a box, is it not? Now, I spent a whole lot of time on this, relating it to what we had done before when we had base, rate, and percentage, and how you could solve for one of those letters from that one formula. I wanted W by itself, I believe, in this case, so I didn't want the L and I didn't want the H. So divide both sides by L, that gets rid of it. Divide both sides by H, that gets rid of it. And so W is V over LH. My argument was that was 30 seconds, if you remembered. Now that's a big if. Sandra.
I did it a totally different way, and I was just wondering, because what I did was I times L times H and came up with 80, and then...
No, whoa. No substitution yet. This isn't part B. This is part A. Just find. No, I'm just saying if you didn't do this, you didn't get points for this part. There's a second part I need to look at. Michael.
Do you have to do the very first step up there with the cross?
If you had just said W is V over LH, I would have understood what you did. I'm trying to illustrate so you can see what was done. But this is the new formula. Now, second part of that problem, as we come back to the document cam, says if the volume is 720 cubic feet, and as I slide over, L is 10 feet, and H is 8 feet, I wanted you to find W. Okay, so to that extent, I have my formula. Let me write that again. And I told you that volume was 720 cubic feet, correct? So I'm going to substitute. Now for the moment, you might have an option here whether you want to put feet cubed or not. I'm going to put feet to the third, just to be technically correct. And then the L, I told you, was 10 feet. So I'll put 10 feet. Then I have a W. I'll put that in parentheses for a moment. And then I had H was 8 feet. So that says, for the moment, 720 is equal to 80W, which I think is where Sandra was talking about. Now, I want W by itself, so I divide both sides by 80, and I get W is equal to 9, which technically was feet. Now, that one went better. But there are two separate parts to that problem. And the first part we had talked about, and it wasn't something that you were doing on your homework, because that was not asked of you. This part was. But if I cover something in lecture, it is fair game on quizzes and tests. And I mentioned to you, as we slide over here a little bit, that this is a very critical part of algebra, your ability to do this. And we had done it in Math 10. This brings up a question then, how responsible am I holding you for what we did in Math 10? A lot. Over Christmas, you can forget a lot of things. What I would be doing is going back and reviewing particularly the formula unit, the percent unit, okay, the how much unit. So if we look at that in terms of what was critical for Math 10, and we said so at the time, the formula unit, the percent unit, and why I'm doing formulas in caps and percent not, I don't know, but we'll let that slide. And the how much, which was dimensional analysis. And then we said the simple closed curve because it talked about graphing. Now there's 4 units that you need to go back and just, if nothing else, look at what you did before. Okay? So to me, this quiz, the first 2 problems you did pretty well on. That was order of operations. That was what we had just finished, of course. But the problems on the areas, of which I gave you 3 with formulas and areas, did not go so well. And as I say, in fairness to you, the classes in algebra, pre-calculus, and calculus that are going on with Sarah, she was more upset than I was. You did better than they did. That's not enough for me. What I'm concerned about is I want you to do at the same level or better than you did in 10. Anything less than that is not good enough. What I think you need to understand, there are some very basic differences in this second effort we're doing on the bridge program, because we're not providing you as many hours in a tutoring session that you can do without having to do things at home. So it comes back to expectation. One, my expectation of you is that you're going to do well. Okay? Because I know what you can do. And the expectation that you should have for yourself should be a commitment to spending outside of class 2 hours per day. Less than that, I don't think you're going to do as well as you should. Okay? So that's where I am after looking at some of the quizzes and just thinking pieces together. But you will see some of these quiz problems on the test you get 2 weeks from now. Any questions? Okay. And I would gather from the fact that you finished the computerized homework, at least I checked all your efforts this morning, just did it now before I booted up for the class, and it looks like you're doing well, so I'm assuming there aren't very many questions from the homework that you did for the weekend. Is that correct on 2-1? Okay. Property time. I was very tempted on that quiz to do something about properties. Just as a quick review, can you list on paper right now 9 of the 11 properties of the number system? Just list them. A, B's, and C's. Know your ABCs. Don't look at them. See what you can do without looking. Using little a, little b, little c are real numbers. What are 9 of those 11 properties? Write what you can. On paper. Have paper out and start writing something. Okay, if you would please. Paper out.
We have to know the name of them?
And write.
We have to know the names of them?
Yes. Names and symbols. Little a, little b, little c are the ones you want. Let's see how many you can get. You should be able to name all 9 of them today. They will be on an exam. Okay, so we'll just wait a few more moments. I think I'll move over here, Jonathan, for A, B, and C belong to, new symbol for you, big R. That means belong to, members of. They're in the club. A, B, and C are real numbers. Now you have 9. We have 11 properties. I want to know the first 9 that can come into your head. Okay, I see blank papers and no activity. Okay, first one. A plus B belongs to what? Big R. It's closure. Belongs to. Is a member of. This is closure. You add 2 numbers, you get a number in the system. Add 2 real numbers, you'll get a real number. And there's a closure for what? Multiplication. AB is also an R. What happens if I add A and B? Should be the same as what? B plus A. That one was what? What is it called? No, associative is regroup. It's the commutative. You reverse direction. Commute. Commutative. Okay. Multiplication. A times B is the same as? B times A. What about A plus B plus C, and I'm going to group them this way, and then over here, regroup them in this way. Doesn't matter how you group. This is what James was referring to as the associative property. And of course, I can do it with what? Multiplication. Do the A times the B first, or do the B times the C first. Get the same answer. What was the identity for addition? A plus 0, correct? Gave you A. And what's the identity for multiplication? Not 0. A times 1 is equal to A. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8 distributive. A times the quantity B plus C, AB plus AC, and we know that as the distributive property. Then, Emily's property. A plus what will give you 0? Negative A. If I add a number to its inverse, I get 0. We said there was one for multiplication. I'm not going to go into that this morning. But now, this is where I want to start today. Now, these properties, I expect you to know. And this morning you didn't. But I'm telling you today, I expect you to know them. So you should study them for tomorrow. Okay? Any question on those? Yes?
Where it says AB equals CA, or is it the A plus B plus C? Oh, okay. That makes sense.
That better? Little waving lines help?
What's the name of that one again? Underneath distributive.
Distributive.
No, underneath.
Oh, this? This is the inverse for addition.
And then there's also an
Inverse for multiplication we haven't done yet. But that's now 10 of them. And what does that have to do with today? Adding sign numbers. Now, there are a variety of ways of teaching sign numbers. In the text, we talk about debits and credits. Mixed feelings about that. If you don't like debits and credits, you don't like accounting, that's not going to do a whole lot. And the other has to do with the number line. I'm going to try a third technique. Now, the first thing to remember, if you add two positive numbers, you get a positive number. Things haven't changed from what we've been doing forever. 2 plus 3 is 5. Nothing complicated about that. And if you think of it in that sense, adding two negative numbers, if you owe $2 to Michael and you owe $3 to Robert, you owe $5 total. So negative 2 added to a negative 3 will give you a negative 5. If both numbers are negative, you get a negative at the end. That isn't the hard part. What if you have a negative and a positive? So I'm going to look at 2 plus minus 5. 2 plus minus 5. That's an addition of two numbers, one positive, one negative. Now, if I don't put a plus in front of the 2, it's understood to be positive. Now, I'm going to rewrite negative 5 in a very special way. You don't have to think anything about debits and credits. You don't have to talk about how far you're walking and what direction you're going in the number line. Here goes. Now, to me, it's this simple. Hopefully, it is for you. Minus 5 can be written as a negative 2 plus a negative 3. Let me just walk off camera for a moment and look at that. Negative 5 is negative 2 and negative 3, correct? Yes. So I could think of this for a moment like, and I'm going to put these in here, I just replaced negative 5 with this. Now I can rearrange the parentheses, correct? Mm-hmm. So this becomes 2 plus negative 2 plus negative 3. What's 2 and negative 2? 0. What's 0 plus negative 3? Negative 3, and you're done. I don't think there's any better way to look at negative numbers than that. The question is, would you want to show all that work? If you don't follow, yes. If you can do it in your head, no. But again, 2 plus negative 5, I just break the negative 5 into a negative 2 and a negative 3. Rearrange, the 2 and the negative 2 go to 0, and I'm left with 0 plus negative 3, which is negative 3. Now, after a while, you'll realize that you can do that pretty much in your head without doing what I just did there. If I start instead with a negative 4, and I want to add that to a positive 5, now I suspect you can look at that and say, oh, I get 1. But can you make it do the same thing by breaking the 5 into what? 4 plus 1, this part is a number and its inverse, which goes to 0. That's 0 plus 1, which is 1. Are we there? Now, it's just using the properties. Now, if I don't do it that way, there is a rule that I don't believe lends itself as nicely as that did. I'm going to go back center, Jonathan, so you know where I'm headed. And I'm going to go to the text and look at the rule that's provided in our text. If you don't want to follow the debits and credits idea, or you don't want to follow the number line idea, and so this is in section 2.2, which is roughly around 109 or 8 where I want to be. Don't want to be in 4. Okay, so let's see. Okay, it's at the top of 106. And if you are comfortable with mathematics at a certain level, I think this makes sense as we go to the document camp. To add two integers, if they have the same sign, meaning both positive, both negative, add their absolute values. Then keep the same sign. So for example, if I'm adding negative 2 and negative 3, what's the absolute value of negative 2? 2. Absolute value of negative 3? 3. Add the absolute values. 2 plus 3 is 5. And use the sign that was common to both, which is negative. So you have your negative 5. Negative 2 plus negative 3. Absolute values 2 and 3. Add them, you get 5. And they were both negative, so your answer is negative 5. In some ways, it's a bit much for what seems, I think, rather obvious that two negatives added together will be a negative number. But if you're going to try to explain that to a person, the absolute value is a nice way of thinking of it. It's the next one that I think, although it's correct, is sometimes hard for people to implement. I'm again on page 106. If they have different signs, subtract their absolute value and keep the sign of the number with the greatest absolute value. Okay. Read it twice, 3 times. See if it makes sense to you. Okay, I'm just going to leave that there. It's a little bit crooked, but that'll do. Going to the sideboard. So the argument here, we had a 2 and a negative 5. And we were adding these. So it's telling me to do what? As we come to the board. Find the absolute values and then subtract. Well, what's not clear is what to subtract. What order? Basically it says if you were with whole numbers and I said to take the absolute value of 2, take the absolute value of negative 5 and subtract, so now I have a 2 and a 5, what's implied? that you're going to subtract the 2 from the 5. Otherwise, you wouldn't get a positive result, which is what you want. So this, to me, isn't quite as clear as I'd like. This then says you're going to take 5 minus 2, which is a 3, and then take the sign from whichever of these an absolute value had the largest value, which is the 5. So it had a negative, so I come out here and put a negative 3. It works. But son of a gun. It seems to me that life is better if I do this and I have no absolute value to work with, and I'm working with the properties. Yes, Lamar.
I do it another way. I do the number line.
Oh yeah, the number line is another way of doing it. But I'm just cautioning you that at some point the number line's not where you want to be. Let me give you a new problem. Oh, and a by the way, BTW. You text message and you don't know BTW. By the way. Okay. Now, if I write 2 minus 5, I trade it in for an addition problem. I never think in terms of subtraction in this way. Now, I realize you can say 2 minus 5 and you know it's negative 3. After a while, you quit thinking about this and you just get an answer. But in terms of what we argue in algebra, and this goes back to that statement I made last week, that we trade in a subtraction for the addition of the inverse. Otherwise, the number you're subtracting, we take the inverse of that and add it to A. That's what's meant. Okay? So question. I give you a messy problem. Let's see. 7 minus 5 plus negative 3 plus 4 minus 2 plus 9. Now, I can just keep throwing digits up there forever. What's the best approach? Now, clearly you can go from left to right, correct? Order of operation because you're just adding and subtracting. Or you can look at this and say, well, let me do this first. And I'll rewrite every subtraction as an addition. Pardon? I don't know. I'm not interested in the answer as much as I am what I'm doing here. Now, collect the negatives all at once. And what do you have? Negative 10. Not 10. You have negative 10. And collect all the positives, which will be 7 and 4, 11 and 9 is 20. Then you understand, if you wish, you can write that as 20 minus 10, which gives you 10. Or you can say that's 10 plus negative 10, but I know this by a number in its inverse gives me 0, and I get 10. Procedure, process may be more important than sitting there and saying, well, 7 minus 5 is 2. That makes minus 1 plus 3 plus 1 plus 9 is 10. Again, 7 subtract 5, that would be 2. Then 2 minus 3 is negative 1. Negative 1 plus 4 is positive 3. 3 minus 2 is 1, and 1 plus 9 is 10. Now, I'm comfortable with that. And this is perhaps laboring the point a little bit more, because I could have just as easily rewritten this. This is the alternative. 7 minus 5 minus 3 plus 4 minus 2 plus 9. But instead of sitting there and subtracting, I still do what? I say I have a negative 5, I have a negative 3, I have a negative 2, and that's still my negative 10. I understand that that means this. And I don't know what kind of background you have, and I don't know how that appeals to you. But this is the one place in a pre-algebra where people sometimes lose it and don't make it. Are there any questions here? Okay, now, it brings up a question implied with Bolmaro's comment. If you have done this successfully, and you use where you are on the number line, and you've never had trouble with it, stay with what works. Stay with the program. If you've never worked with negative numbers, or it's always been a hassle for you, I would strongly recommend that you think in terms of a step like this, breaking up the 20 into a 10 plus 10 so it can offset with the inverse idea and get a 0 here. And all the times I've tried to present addition with integers, I've never found anything that works any better for me or for the students than this idea of the inverse. Now, if I have negatives, and technically this section isn't dealing with subtraction, but if I take negative 5 and take a negative 3, I'm going to change that. Let me get an eraser. That's obvious, too obvious. That's negative 5 plus negative 3, which is negative 8. I need a little more space there. Negative 5 minus a minus 3. Now, negative 5 and subtract negative 3. So, in terms of what we've talked about before, what can I add to negative 3 to get negative 5? And the answer is negative 2. The Austrian approach. Again, I'm taking negative 3 from negative 5, so that's written this way. What can I add to this negative 3 to get negative 5? And a negative 2 and a negative 3 will get me there. That's the Austrian method. However, I could say that is minus 5 plus the inverse of negative 3. But what is the inverse of negative 3? You need to know that's 3, and that's the negative of a negative. Think of it as, again, the unseen 1. So negative 1 times negative 1 is 1. We haven't talked about multiplication, but that would be what is involved. For predicate logic, it's the double negative. The negative of a negative coming out the positive. So that means this is really this problem. And then that's negative 2 plus negative 3 plus 3. That goes to 0. And so you have negative 2. That's where I'd like you to be. Again, any questions there? Michael.
I'm comfortable with the first way that you did it.
Okay, sliding over to the left now. We're referring to this problem?
Yeah.
Okay, a little bit more, Jonathan. And up here? Or here?
Well, yeah. Well, both those.
Okay.
But the one below, I mean, that's like,
This down here?
yeah, that seems kind of odd.
Well, it's pushing the issue, but how can you defend that 20 plus negative 10 is 10? Now you could say, well, I'm going to treat the addition of a negative as simply a subtraction problem. Yes. Or I can argue that 20 can be parsed into, separated into 10 plus 10, because I know negative 10 has an inverse of 10 that makes these two give me 0. The identity added to 10 is 10. This is the easy way. I concur. This is growth. This is where you're going to have to be in an algebra class, because you will be expected to defend that using the properties. So this is defense with properties of the number system. And that is the first chapter of a Math 70. And that's where I start with 70.
So you're going to want to see this.
Well, at the moment, I'm not going to sit there and analyze how you find the sum of negative numbers. But if you are having trouble with it, or if you're wanting to know how should I think about it, this is a good direction to go. I can give you shortcuts. I can give you ways of getting around it, as we did here, doing this little rewrite. But this is very critical. I'm using the properties. And I'd like to stress that. Now, if this was a generic, everyday Math 20, I would have such a diverse background represented, not knowing what people have had before. I wouldn't push this, but I know what you've had, and I know what you're capable of doing, and I want to push you in the right direction. And this is a direction that will help you in a 70, okay? And it is a place where some difficulties occur. I'm going to leave that just as it is, and then I'm going to go back center, so we'll leave that. Then I want to come back to the book. And you can read through what's in the book with the credits and the debits and the number line, and you may find something that appeals to you. And I have no problem with that. Bottom line, you need to be able to add integers. You have to find what works for you. You have to do it well, and you have to do it quickly. The illustration I just gave deals with this problem on page 187, where you combine the positives and the negatives as we go to the document cam. And what, of course, is not done here is explain how you get the negative 23. And if you want the usual, well, what's the difference of 41 and 64? It's a 23, and the negative 64 has the larger absolute value, so that becomes a negative 23. I'm at the top of page 107. And so the argument, add the positives, add the negatives together, and life is going to be pretty good. So as we come off there, and as you read through these problems and the explanations, there's not a heck of a lot to read other than 3 different approaches to how to do the problems. And some of them, as what we look at in the homework, are rather easy. So, for example, here's the 10th problem on page 110. And I hope it's nearly trivial to you that you get a negative 40 there without pushing it. Now, you might ask yourself a question. Of course, you might not. But you might ask yourself this question, as I leave that there. How can I do that with one of the properties? How can I make that work? What could I do? Number 10. Can you do it with a property? Can't do it with the inverse. Can't do, back to the problem one more time, Jonathan, just so I can see it, negative 31 plus negative 9. This is number 10. None of the above. Nope. No, I'm just saying, is there a way I can do a property that will get me to the answer nicely?
Yeah, distributive.
Yes. Very good, Sandra. See, this is really negative 1 times 31. We haven't said that the negative times the positive is that, but it indeed will be. And then factor out the negative 1 and have 31 plus 9 left here. So that's negative 1 times 31 plus 9. I didn't need that. I should have replaced that immediately with 40. Negative 1 times 40, which is negative 40, using the distributive property. Okay? What we do say is the additive inverse of a sum is the sum of the additive inverses. One more time. The additive inverse of this sum is the sum of these additive inverses of each one. That you need to know. Put a minus sign out in front. It changes each one to a negative and you add them. This is important. Okay. No, it's using the additive inverse of a sum defended by a distributive property. Michael.
Sounds like you just said the same thing twice.
The additive inverse of a sum is the sum of the additive inverses. Like the square root of a product is the product of the square roots. Not the same thing. Okay? This is important also.
You said the additive inverse of what?
A sum. When I have two things added together, it's a sum. The additive inverse of, in parentheses, a sum is, if you wish, the sum of the additive inverses. The parentheses optional. This is not true. So it's not always the case where I can use language like that. If you would please, Jonathan, drop it a little bit more. There we go. So the square root of a sum is not the sum of the square roots. The language and these generalizations are very important. That's where the algebra comes in. Let me leave that, come back to the book. It's not until we get down to something like 44 that there's any particular work here, and I think you're going to find that, like 44, it's pretty much a slam dunk. Because what are you going to do? 44, I'm going to add the positives, so that's a 40 and a 16 and a 3, which is 59. Add the negatives. Negative 59. 59 plus negative 59? 0. Now here's the danger. So we come off there. Doing it in your head and knowing what you did today, seeing it tomorrow and have no idea. Original problem, intermediate step, and answer, minimal documentation. Original problem, intermediate step, and answer. Formula, substitution, and answer when you find areas and volumes, etc. Now beyond that, these problems, I suspect, in a half hour, you'll have them done. Is that enough to do to really put it together for you so that it's automatic? That I don't know. What makes it automatic for you? Lots of repetition, and that's going to be critical. I mentioned to you that subtraction is replaced by addition. And since I've talked about that, I'd like to at least show you where it is on page 115. The top of the page. To write a subtraction as a statement, as an equivalent addition statement, change the symbol from a minus to a plus, and then change the second number to its additive inverse. I want to leave that there. Notation versus language. I want you to read that a couple times. And I want you to ask this question in your head. Which of this versus the English? Bring that in tighter. Let me step back. Let's bring it in. which is the clearer statement? A minus B equals A plus negative B, or the statement we have here at the top of page 115 as we go back to the document cam. I'm going to bring that in tighter. We want to take a subtraction as an equivalent addition. So it says change the symbol, the subtraction symbol, from minus to plus. And then change the second number to its additive inverse. Coming back to the board again. Now, I don't know what works best for you. I'll tell you my own philosophical position. What you see in the board on the monitor has a clarity that nearly gets lost in the English verbiage. Jonathan, if you would please, coming off. Try again. Thank you. And that is back to Bertrand Russell. A good notation has a subtlety and suggestiveness that at times makes it like a live teacher. If there's any one thing that I would argue for throughout this entire semester, learn to value notation. You will be inclined to run from it. Jonathan, I want camera 2 now up in front, please, on the properties. If you would, please, so bring camera 2 around. I want that in the properties. Because that's the notation, and I want that written out at the beginning of class tomorrow before we start our broadcast in a very quick quiz. So as we go to the board. These properties, got 10 of them so far, and I would expect you to be able to write the 10 in notation and name them for 10 points that I'll use to replace either of your 2 low quiz grades. Hear it again. 10 properties with notation. That's what this refers to. And the names. 1 for each. 10 points max, and I'll replace either one of your low quiz grades from the first 2 quizzes. That'll be done before class, and you'll have 10 minutes or less to do it. From memory, no notes. Michael.
The first one, closure, that's 3 properties?
2 properties. This just said if you have 3 elements, A, B, and C, 3 numbers in the real number system, then the sum of 2 real numbers is a real number. The product of 2 real numbers is a real number. And that is called closure for 2 properties. So 2 here, 2 for commutativity, 2 for associativity, 2 for identity. 1 distributive and 1 inverse. I haven't given you the second inverse for multiplication as a property here, but what it is, we might as well go a bonus point on the extra credit. This is for Emily. The inverse for multiplication. For multiplication. A times 1 over A equals 1. For any number I give you other than 0, there is a reciprocal of the number. Okay? So for any number I give you, and I should be done, shouldn't I? I'm sorry, that's Brian saying I should have finished. Yeah. Yes, I should have. Let me go to slide and music, and we'll do that. I was getting carried away. Let's go to slide music, and I'll finish this off.